What happens if you fall into a black hole? Is it a one-way trip into oblivion? Or is there something beyond the event horizon that even the greatest minds in science haven't fully grasped yet? Today, on Mind Stretch, we're diving into one of the universe's most mysterious phenomena, black holes, and we're going to unravel what could lie beyond the event horizon. Welcome back to Mind Stretch. Let's stretch your mind today by looking into what happens when you approach and pass the event horizon of a black hole. So, what exactly is a black hole? At its core, a black hole is formed when a massive star reaches the end of its life and collapses under its own gravity. The gravitational pull becomes so strong that even light can't escape, making it completely invisible. There are different kinds of black holes. Stellar black holes are formed from collapsed stars, but then there are supermassive black holes, the real giants lurking at the center of galaxies, including our own Milky Way. And while it's just theoretical, some scientists think that primordial black holes, tiny but incredibly dense, might have been formed in the early universe. Now, here's where things get really strange. Surrounding every black hole is a boundary called the event horizon. Think of it as the point of no return. Once something crosses this line, there's no escape, no matter how fast it moves. As you approach the event horizon, something even more bizarre happens. Time slows down. Imagine a clock ticking slower and slower the closer it gets to the black hole. This is called time dilation, and it's predicted by Einstein's theory of general relativity. From the perspective of an outside observer, anything falling toward the black hole seems to slow down and almost freeze in time as it approaches the event horizon. But for the object falling in, time continues as normal, and the event horizon is just another step on the journey. What happens after you cross the event horizon? That's where things get really, really weird. The gravitational pull of a black hole is so intense that it causes something called spaghettification. If you were unlucky enough to fall into a black hole feet first, the gravitational force at your feet would be so much stronger than at your head that you'd get stretched out like a piece of spaghetti. Your entire body would be elongated and ultimately torn apart. Not the most pleasant way to go. But what's beyond this extreme stretching? At the very center of a black hole lies what scientists call a singularity. This is a point where gravity becomes infinitely strong and space and time as we know them cease to exist. The laws of physics break down entirely. No one knows exactly what happens here. Does the matter that falls into the black hole get crushed into an infinitely small point? Or could there be something else? Something science hasn't yet discovered? This brings us to one of the biggest puzzles in modern physics, the black hole information paradox. According to quantum mechanics, information about matter can't be completely destroyed, but black holes seem to defy this rule. Anything that crosses the event horizon seems to be lost forever, right? Enter Hawking radiation. In the 1970s, Stephen Hawking theorized that black holes emit tiny amounts of radiation. This radiation causes black holes to lose mass and eventually evaporate. But if a black hole disappears, what happens to all the information that fell into it? This paradox has stumped scientists for decades. Some suggest that the information might be encoded in the radiation itself, while others believe we're missing a key part of the puzzle. So, what if black holes don't just destroy everything they pull in? Some physicists speculate that black holes might be gateways to other points in the universe, or even other universes entirely. One theory suggests that black holes could act as wormholes, tunnels through space-time that might allow travel across vast distances in a fraction of the time. But this remains highly theoretical. Another possibility? Black holes could be the seeds of new universes. Some scientists think that when a black hole forms, it might create a new universe on the other side, separate from our own. It's all speculative, of course, But when it comes to black holes, the possibilities are as vast as the universe itself. So, how do we even study something as mysterious and invisible as a black hole? One way is by detecting gravitational waves. When two black holes merge, they send ripples through space-time, which scientists can detect using incredibly sensitive equipment like LIGO. And in 2019, humanity got its first ever image of a black hole, thanks to the Event Horizon Telescope. This groundbreaking achievement gave us a glimpse of the supermassive black hole at the center of galaxy M87, an eerie, glowing ring surrounding the dark shadow of the event horizon. These discoveries are just the beginning, and there's so much more to learn. Black holes remain one of the most fascinating frontiers in astrophysics. Black holes challenge everything we know about physics. They force us to rethink the nature of space, time, and even reality itself. What lies beyond the event horizon? We don't have all the answers yet, but one thing's for sure. Black holes will continue to stretch the limits of our imagination. Thanks for watching Mind Stretch. If you enjoyed this video and want to explore more of the universe's greatest mysteries, hit the like button and subscribe. And let me know in the comments, what do you think happens inside a black hole? See you next time, and remember, keep stretching your mind.